Everyone fits into one of four categories of blood types: A, B, AB, or O. And then there's another feature in blood typing that we consider, and that is the Rh factor. The ABO types are all based on the presence or absence of A and B antigens on the surface of a red blood cell. The Rh factor simply indicates whether or not the Rh antigens are present. Blood type is determined, first of all, through the surface antigen of a red blood cell. Surface antigens are also called agglutinogens. Another very important factor in blood typing is the antibodies that are present in a person's blood. Antibodies are also called agglutinins. The problem lies in if you get the antibodies and surface antigens together, you get agglutination. Agglutination is where the antibodies, which have two binding sites on their Y-shaped molecule, bind to the matching antigens. Notice here that there are two cells that are now bonded together by the antibody. When you get a mass of these cells all bonded together, you have what's called agglutination. Now be very careful, agglutination is not coagulation. Coagulation is blood clotting. Following this agglutination, the red blood cells are destroyed in a process called hemolysis. Blood type A, these people have the surface antigen A on the red blood cell. Now you never want the matching antibody in the blood with the antigen, so it's always going to be opposite. A blood type A has the anti-B antibodies. These people can donate to people who are either type A or type AB. You can donate to a type AB because AB does not have anti-A or anti-B antibodies. Now, if they need to receive blood, they can receive blood from another type A, but also from a type O, because a type O does not have any surface antigens. Type B blood. Here we have type B surface antigens. Again, we have the opposite antibodies with a type A antibody. Excuse me, let's state that properly, an anti-A antibody. These people can donate to their own blood type of type B, also to type AB for the same reasons given for type A. They can receive blood from a type B person or from type O. Blood type AB has both the A and the B surface antigen on the red blood cell. Because both of those antigens are there, if you have this blood type, you do not have any antibodies. These people are called the universal recipient because they can receive blood from type A, type B, type AB, and type O because they have no antibodies. However, they can only donate to themselves because all of the other bloods have the antibodies that match the antigens that they have. Type O does not have any antigens. These are the universal donor. Because there's no antigens, they can go into any of the bloods, A, B, or AB, because there is nothing to react with the antibodies. However, they do possess both anti-A and anti-B antibodies, which makes them very limited in who they can receive blood from. A, B, and AB all have A or B antigens. Type O has the antibodies. So they can only receive blood from another type O person, but they can donate to all of the others, making them the universal donor. The Rh factor. Now, it's called Rh because they were discovered in rhesus monkeys initially. At first, there were a number of different factors that were identified, and as time went on, it was discovered that it only mattered if the Rh factor was there or not. An Rh positive person has the Rh antigen. Because they have the antigen, and because we do not want the antibody matching the antigen in the same blood, they do not have an antibody. An Rh negative person does not have the Rh antigen, but once they have been exposed to the antigen of an Rh positive blood, they begin to form the antibody. We call this sensitization. Now, this is not true with ABO blood types. Those individuals are producing the antibody from birth. Rh negative people, however, don't until they're exposed to the antigen. In the case of transfusions, we want to be certain that we have the correct blood type, even with tissue transplantations. A story that I remember very clearly happened several years ago. It was at Duke University. 17-year-old girl went in for a lung transplant. Somebody mismatched her blood and they gave her the wrong tissue. As quickly as possible, the transplant team did a new transplant with the correct tissue, but for this 17-year-old girl, it was too late. She still lost her life. So what happened there is that she had a cross reaction, which resulted in agglutination and hemolysis. Typically, a cross-match testing will be done prior to transfusing blood. If there's an agglutination in a cross-match testing where they've taken the donor's blood and the recipient's blood and mixed them, it means that the antibody and the antigen are both there. That's bad news.